the PV diagrams. That means different types of PV diagrams we are drawing. Ready? The PV diagrams. We know that work done is integral of dW from minimum volume to maximum volume, which is same as PdV from V1 to V2. Work done is integral of dW, which is PdV from V1 to V2. Written?
Sir.
Right. The integral in the equation can be represented graphically. The integral in the equation can be represented graphically. Thus, area under the curve in the PV diagram, area under the curve in PV diagram is the graphical representation. Area under curve in PV diagram is the graphical representation of the value of integral PdV. Representation of what value of integral PdV. This represents work done in the process. This represents work done in the process. In the case 1, gas expands. Case 1, gas expands. That means PV diagram for the case when gas expands. If gas is expanding at constant temperature, then volume is increasing or decreasing?
Increasing, sir.
Volume increases. If volume increases, then work done is said to be positive. Gas expands, graph I am showing. Pressure P, volume V. This is isotherm, increasing volume V2, original volume V1. This is pressure P1, pressure P2. Here work equals to integral of PdV from V1 to V2, and it is positive because volume is increasing. Area under graph is PdV greater than 0. Just draw this graph, first one. Work done is positive because volume has increased. Case 2. Gas contracts. Case 2 diagram completed.
Yes, sir.
Below that diagram, write down the work done is negative because volume of gas has decreased. Because volume of gas has decreased. Case 3. Case 3, positive work at constant pressure. Positive work at constant pressure. Case 3. Case 3, positive work at constant pressure. Pressure, volume, Here pressure P is constant. Hence, graph is parallel to volume axis. The work done at constant pressure, comma, W equals to P into V2 minus V1.
Done, sir.
Case 4. Case 4. Volume is constant. When volume is constant, then work done is zero because there is no displacement. In this case, change is very slow. Yes. Done then, Sela.
क्या सर?
Completed full.
हाँ सर, हाँ सर.
Next heading. Thermodynamic process. See, whenever we say thermodynamic process, that means it is a procedure by which initial state of system changes to final state, and state means function of PVT. So when pressure, volume, temperature initially becomes PVT finally, then that process is called thermodynamic process. During this chain, there may be transfer of heat into the system from the surrounding. That means from outside system may absorb the heat, it may be positive, or sometime it may release the heat, then it will be negative. Like when water boils, then heat is absorbed by the water. This may be sometimes released. Hello? Okay, just write meaning of one word, thermodynamic process. A thermodynamic process, they can ask for 1 mark. What is thermodynamic process? A thermodynamic process is a procedure. A thermodynamic, a thermodynamic process is a procedure by which the initial state of a system changes to its final state. Initial state of system changes to its final state. During such a change, the heat may be absorbed by system or released by system. When absorbed, then you will take positive. When released, you will take negative. Next line. Similarly, some work.
Done, sir.
नहीं, नेक्स्ट 10 और बाकी है ना, 3 प्रोसेस आएगा, ये तो जनरल कर दिया. हीट हो गया, एनर्जी हो गया, वर्क आएगा ना. नेक्स्ट लाइन. Similarly, some work can be done by the system or some work can be done on the system. Some work can be done by the system or some work can be done on the system. These changes must occur in finitesimally slowly so that the system is always in thermodynamic equilibrium. Such process in which the changes in the state variable means pressure, volume, temperature. In the state variable of a system occurs infinitesimally slowly are called quasi-static system. called as quasi-static system. Yes, completed. Such process in which changes in the state variable of system occurs infinitesimally slowly are called quasi-static system.
Done, sir.
When a thermodynamic system changes from its initial state to its final state, it passes through a series of intermediate states. These series of intermediate states plotted on a PV diagram is called as path. It's called as path.
Done, sir.
जरा एक मिनट रिवाइज कर लो जो जो किया अभी तक, मतलब आज का टॉपिक जो भी किया, जरा एक मिनट पूरा क्रॉस चेक करो, because it is full of theory and based on theory there will be graphical questions in the exam. Yes, done. Division. यस, चलो अभी देखते हैं, हो गया ना रीड करके.
Yes, sir.
Work done during thermodynamical process. See, we studied three cases. Volume will increase, volume will decrease, volume remain constant.
Sir, 4 na?
A fourth, volume increases, volume decreases, pressure constant, volume constant. बराबर?
Sir. Sir.
So now we are combining all the process for path. So this is PV diagram for different process. Suppose we start from initial state A, go to B. This is positive work or negative work?
Mm,
What it will be, positive work or negative work?
Negative work, sir.
What is meaning of negative work?
Means yeah.
वॉल्यूम कम होएगा तो नेगेटिव वर्क बोलते हैं. वॉल्यूम ज्यादा हुआ है ना इसमें, राइट
अरे
साइड क्या
हाँ,
है, मतलब
sorry, sir.
वॉल्यूम ज्यादा हो गया ना, राइट साइड पे गया तो वॉल्यूम ज्यादा, तो पॉजिटिव वर्क. So if I consider process from A to B, volume is increasing, then it is positive work. Correct? Hello?
हाँ सर, समझ गया.
Path one क्या है, पॉजिटिव क्या नेगेटिव?
Positive.
A to C. A to C along path 2. What is A to C? Constant pressure क्या constant volume?
Sir, constant pressure.
Constant pressure. So this time what is work done? PdV, pressure constant, only volume is changing. In C to B, what about pressure? Constant or variable?
Sir, it is not constant, sir.
Pressure is not constant, volume is constant. So what will be work done? Zero. Work done will be zero, correct? Volume constant
Yes, sir, yes.
in BC. अभी थर्ड वाला पाथ इधर से स्टार्ट करते हैं. A to D and D to B. In this case, what about volume? Increases or decreases?
Decreases.
नहीं, फाइनल वॉल्यूम इंक्रीज हुआ है. ए टू बी, ए से स्टार्ट किया, डी पे गया, फिर फाइनल इंक्रीज हुआ.
हाँ सर.
दो प्रोसेस है इसमें. तो ये डायग्राम बनाओ, इसको एक्सप्लेन करना है. ये समझ गया तो आपको इसका रिलेटेड ही सम आता है एग्जाम. ड्रॉ डायग्राम फॉर ऑल दिस प्रोसेस. A to C, A to B, C to B, then ADB. आराम से करो, बहुत स्लो जा रहा हो बिकॉज ये चैप्टर बहुत लेंदी है. फर्स्ट टाइम इंट्रोड्यूस हुआ है एज अ सेपरेट चैप्टर, सो आई फील क्या वेटेज बहुत ज्यादा होएगा इस पे. ओके डन.
हाँ सर, हो गया.
राइट, कंसीडर a system, consider a system initially at state A on PV diagram. Consider a system initially at A on PV diagram. Its pressure is Pi, Pi means initial, and volume is Vi. Thus, initially system has coordinate Vi, मतलब x coordinate, y coordinate, comma Pi. The final state of system is represented by point B having coordinate Bf, comma Pf. That means see, initial is A, final is B. You can go through path 1, you can go through path 2, you can come through path 3. So from 3 paths we have started from A and reached to B. Just complete till this. Initial state A, whose coordinates are Vi, Pi. Final state B, whose coordinates are Vf and Pf. Right. Thus, we can go from initial state to final state through 3 different paths. Through 3 different paths. When system changes itself, when system changes itself from A to B along path 1, both pressure and volume, both pressure and volume are changing. both pressure and volume changes. Right, the pressure decreases while volume increases. The pressure decreases while volume increases. The work done is positive. The area under graph is work done. This is as shown in curve 1, and then draw this diagram. Drawn full?
Yes.
Right. The second way to change the state from A to B second way to change the state from A to B is along path 2. Is along path 2. In this case, volume increases from A up to C. Volume increases from A up to C at constant pressure Pi. At constant pressure Pi. The pressure then decreases to Pf and volume remains constant. The work done in the process is represented by shaded area under the curve as shown. Work done in this process is represented by shaded area under the curve as shown. Now draw this diagram. Next paragraph. When the change in state from A to B, when change in state from A to B is along path 3, when change in state is from A to B along path 3, then pressure decreases from Pi to Pf at constant volume Vi. Pressure decreases from Pi to Pf at constant volume Vi. Then volume changes from Vi to Vf. Then volume changes from Vi to Vf. At constant pressure Pf. The work done in this process, the work done in this process is represented by shaded area under the curve 3. Then draw the diagram. Completed diagram?
Yes, sir.
Thus it is seen that the work done is different in all the three cases. The work done is different in all the three cases. This shows that work done by a system does not depends upon only initial and final state, but also the path along which changes takes place. So sometimes they can ask you work done is path dependent or path independent. Work done is path dependent, not state dependent. Okay, next heading. Heat added during thermodynamic process. Heat added during thermodynamic process. So here they can ask, explain. Heat added to the system also does not depends upon path. Heat added during thermodynamic process. Heat added during thermodynamic process. Right. Thermodynamic system, thermodynamic state of a system can be changed by adding heat. By adding heat. Thermodynamic state of system can be changed by adding heat. Consider a thermodynamic system consisting of an ideal gas enclosed in a cylinder fitted with frictionless, weightless, airtight piston. Let volume be changed from initial volume Vi to final volume Vf at a constant temperature. At a constant temperature. Again, if completed, tell.
Done, sir.
Temperature we are keeping constant and allowing the gas to expand from initial to final. This can be done by two different ways. Now imagine this is one cylinder fitted with piston. Gas is at having initial volume Vi, then it is heated. Then gas is heated so that it expands and becomes Vf. Okay, draw first diagram. There are two ways by which we can increase the volume. One is by heating the air. First state, second state. Simple cylinder fitted with piston, initial volume Vi, heated, final volume becomes Vf. Work done will be positive in this case because volume has expanded. Done?
Yes, sir.
Right. There are two different ways. There are two different ways in which volume can be changed. Volume can be changed. As shown in figure 1 above, the gas is heated slowly so that it expands at constant temperature. So that it expands at constant temperature and reaches to final volume Vf isothermally. At constant temperature so that it expands to final volume Vf so that it expands to final volume Vf isothermally. Isothermally means no change in internal energy. The system absorbs finite heat. System absorbs finite heat in this process. 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 In second method, as shown in figure 2, this is figure 2. It is insulated, or insulation is done so that heat is not taken or released. This is initial volume. Here we have vacuum Vi dash. This is the gas. Till this it was vacuum. Now it is fully filled. That means Vf equals to Vi plus Vi dash. In second method as shown in figure 2. Right, the gas cylinder is now surrounded by insulating material. Is surrounded by insulating material. And is divided into two compartments. X and Y. Two compartments X and Y. By thin breakable partition. The compartment X has volume Vi and compartment Y has volume Vi dash such that Vf equals to Vi plus Vi dash. The compartment X is filled with same amount of gas at same temperature. The compartment X is filled with same amount of gas at same temperature as in case 1, and compartment Y is empty, Thus initial state in both case 1 and case 2 are same. Thus initial state is same in initial state in case 1 and case 2 are same. The partition is now suddenly broken. The partition is now suddenly broken. This causes a sudden uncontrolled expansion of volume of gas. The gas occupies volume that was empty before partition is broken. The gas occupies volume that was empty before partition is broken. There is no exchange of heat. There is no exchange of heat in this case. But final volume becomes Vf. In this case, gas has not done any work. In this case, gas has not done any work. During expansion. In this case, gas has not done any work during expansion. because it has not pushed. In this case, gas has not done any work during expansion because it has not pushed. Any piston. It has not pushed any piston or any other surface because it has not pushed any piston or any other surface for its expansion. Such expansion is called as free expansion. It's called as free expansion. It is experimentally observed that when ideal gas undergoes free expansion, there is no change in temperature. When ideal gas undergoes free expansion, there is no change of temperature. Thus, in this case also, final state remains same. In this case also, final state remains same. This shows that the path during two cases are different, but initial and final state is same. In first case, there is exchange of heat, and in second case, there is no exchange of heat. In first case, there is exchange of heat. In second case, there is no exchange of heat. Thus, heat transferred to a system. Heat transferred to a system also depends on the path. So that's all for today. Please keep on